Lesson 47, Graphing Exponential Functions. So an exponential function just means that the exponent will be x. So you know when you do a line, it's y equals mx. Well, in exponential, the x is not a factor, it's an exponent. So here's an example, or this is a generic form of an exponential function. Y equals a b to the x. So x is a real number. A does not equal 0. B is greater than 0, but not equal to 1. So if b equals 1, it's just a very boring function, because it wouldn't matter what x is. And if a were equal to 0, that would be boring too. So b can't be 1, and it has to be greater than 0. So here's what it looks like on a graph. This is just y equals b to the x. So it's just where a is 1. So y equals b to the x. So when x is 0, b to the 0 is just 1. So it's going to go through the point 1. When x is 1, b to the x is just equal to b. So up here at b somewhere, whatever b is, goes there. And it gets close to the y-axis but never touches it and comes up like that. So it's super steep, and it doesn't ever pass the y-axis or equal 0, because if you have a negative exponent, it just gets smaller and smaller because it's a fraction. So it'll get smaller and smaller, it'll never equal 0, and it won't equal a negative number ever. So vertical asymptote. There's not a vertical asymptote. It's a horizontal. Horizontal asymptote is on the x-axis, or is the x-axis. Since it will never cross it or touch it, that becomes an asymptote. And just by definition, asymptote is just a line that a graph approaches but never touches or crosses. Well, I think you could just say but never touches. Okay, so here's an example of an exponential function, y equals 3 to the x. So if we were to draw it, the x-axis is the horizontal asymptote. When x is 0, y is 1. When x is 1, y is 3. And then it just goes up from there. The domain for this exponential function is all of x such that x is contained in the real numbers. The range is y's such that y is greater than 0. And the asymptote is y equals 0. Because it's horizontal, it's y equals. If it were vertical, it would be x equals. Now, here's an example where we have b equal to a fraction, so y equals 1/3 x. So this is just like y equals 3 to the x, but it's reflected in the y-axis. So when x is 0, y is still 1. But when x is 1, it's going to be at 1/3. And when it's -1, when x is -1, that's when you're going to get the 3. So it comes up here. So the asymptote is still y equals 0. The domain is all real numbers, so x such that x is contained in the set of real numbers. And the range is the same. It's all the y such that y is greater than 0. And this particular graph is just a reflection of y equals 3 to the x power. So we're going to talk about the parent function and how the different values will change what it looks like. So we already saw that if b is less than 1, less than 1 if it's a fraction, it's going to be a reflection. So we're going to talk about all the different graphs and how they're going to look. So the parent function is y equals b to the x. That means a is equal to 1 in the parent function. So if we are looking at y equals a times b to the x power, if the absolute value of a is greater than 1, there's going to be a vertical stretch. That means it's going to be vertical stretch. So it's going to be closer to the y-axis. If 0 is less than the absolute value of a, which is less than 1. So that means if a is a fraction between 0 and 1, doesn't matter if it's positive or negative, you're going to have a vertical compression, which just means it's going to get wider or fatter. If a is less than 0, so if a is negative, it's just going to be a reflection in the x-axis. It's just going to go down into the third and fourth quadrants. Now, if you have y equals b to the x minus h power, and then plus k. So there's going to be some shifts here based on the h and k. So the h, it's going to shift horizontally h units. Because this is a minus h, if h is positive, if you see a minus sign, you're going to be going to the right because h is positive. So if you see the minus, that means h is positive and you're going to the right. If you see a plus, that means h is negative and you'll be moving to the left. And then it will shift vertically k units. So if you see a plus sign, it's going up that many units. If you see a minus sign, it's going down. So these are kind of very helpful when you're graphing your exponential functions. Okay, that's the end of the lesson.